In this video, we're going to start looking at the basics of hypothesis testing. And this is really going to be an important topic for the rest of the course and really setting up everything else that we're going to be doing in this course from this point forward. So we're just going to focus first on the basics before we get into any of the tests that we'll be talking about. So I'm just going to share my screen with you and we'll get started. As we're laying the foundation here for doing our hypothesis testing, what we really want to do is to start thinking about what is hypothesis testing and what does that even mean? And so we start by thinking about what is a hypothesis? How do we test a hypothesis? What does this process look like? And this is really going to set up a lot of what we're going to be doing because most of this course is us looking at data. And so really a lot of what we're discussing in this small bit of the video is going to be focusing on what happens before the data is collected and how the data is going to be collected. And when we think about what a hypothesis is a prediction. And particularly in our case, it's going to be the prediction that's tested in our research study. We can create a hypothesis based on observation, previous research, or theory. And again, at the point that we're going to be looking at, the hypothesis is really already going to have been made, although we're often going to try to reword it and kind of take out of an example what their hypothesis is. But the idea of kind of this concept of the study, the prediction that's being made in that particular study. So for instance, there might be previous research that suggests that a specific kind of therapy is going to lead to fewer depressive symptoms. Or I might make an observation that when I got less sleep last night, I feel grouchier and more frustrated today. And so I could design a study to test that, to see if less sleep leads to more frustration. And so that's the kinds of, these are the kinds of ideas that we're going to be thinking about when we're looking at predictions, when we're looking at hypotheses. And now we're thinking about, so how do we test that? I have this idea, and how we test that is there's going to be some kind of study run, and then how do we use that data to test this hypothesis? But before we get there, we have to think about what we're doing in order to get that data. And so if I want to test if a lack of sleep makes people more frustrated during the day, I have to think about who am I studying in order to find that? Who is my population? And the population is the group that the researcher is actually interested in. And so in my case, if I just want to know if less sleep makes people more likely to be frustrated the next day, then my population is everybody who sleeps. It's everyone. But that's going to be really, really difficult for me to test if I think that I now need to go and get in touch with everyone in the world to ask them about or put them into some kind of study to test if less sleep is going to make them more frustrated. So whether I'm surveying them or asking them to participate in some kind of an experiment that I've designed, this is really not going to be feasible. And in my case, my population is really big. My population would include everyone. But even if I just wanted to look at statistics students at New York Tech, or if I wanted to look at college students in New York, these are smaller than everyone in the world, but it's still not going to be feasible oftentimes for me to get in touch with every single individual in my population. There's also the case that sometimes people who are in our population might not want to participate. They might just choose not to. They might ignore our request. And so it's not always going to be possible to do this. And so we have this idea of a sample. We take a sample, we take a subset of our population, and these are the people that we're going to study. And so we're going to be consistently making this distinction between our population, the group that we care about, the group that we're interested in, and the sample, the group that we're actually testing, the group that we're studying. And statistics that are based on these methods are called inferential statistics, because the idea is that we're studying our sample, but we want to use that sample and use the data from that sample to make inferences based that would then reflect back these inferences that we hope and that should then tell us something about our population actually. We're not studying the sample because we care about the sample. We study the sample because we care about the population. And so in the images here on this slide, I see this pot of pasta, and if you're making pasta at a certain point, you have to decide, okay, when is it done? And often the best way to do this is to taste just a couple of pieces. You don't want to taste the entire pot, because then that's your dinner, and anyone else that you're cooking for is going to be angry. It defeats the purpose. It's not feasible for me to taste every piece of pasta to test that every piece is done. So I take a sample. I take a few pieces, and that's the sample that I study. And if that part's done, then I infer that the rest of the pasta in the pot is also going to be done. And this is more practical. This goal is that we're going to be able to make generalizations, make predictions. We're going to be able to infer back to our population. And this is oftentimes far more feasible. And these statistics are designed to test hypotheses in this situation. And so obviously we're going to be working with people, not pasta, but so we can take a sample from our population, test these individuals, and that's how this hypothesis testing procedure is going to work. And we'll be talking lots about samples and populations. So where do we get our people? How do we sample them? The best case scenario is going to be random selection. This is the idea that anyone that's in our population could wind up in our study. And that's the ideal for a lot of reasons that we're not going to go into right now. The most important things really to think about with our sample is that we want our sample to be as unbiased as possible. We want our sample to be representative. We want our sample to look like a little microcosm of our population. That's the best case scenario. With a haphazard selection, then this is not randomized. Not everyone has a chance to be in our sample. Haphazard selection is the idea that whoever is available, whoever happens to be first, whoever we come across is maybe going to be our sample, not based on random chance, like in a random selection. This method of selection might also be called a convenience sample at times. We just pick a group of people who are convenient. Maybe I want to study college students in New York, but the most convenient sample that I have are students at New York Tech. And so I'm going to enroll a bunch of students from New York Tech into my study. And this is going to, I hope that this group is going to be representative of college students in New York. But that may or may not be the case. I've just picked the group that's convenient. Not every college student in New York had a chance to be in my study. And this method of selection can result in a sample that's not representative of the population, which is why it's not ideal. Generally, we'll try to control for what most likely matters, or we'll try to make sure that we limit the conclusions that we draw so that it fits the sample that we studied. We're not going to extend our findings to people who were not the kinds of people that we studied. Thinking about samples and populations, one of the ways that we'll be thinking about this, and one of the ways that we'll really be marking this as we move forward is in these symbols as we talk about these statistics. And so we've already talked about sample statistics. We had these symbols, things like M and SD and SD squared, that were the symbols that we used to show our statistics when we talked about mean and variance and standard deviation beforehand. And when we were working specifically with samples, we were taking the mean or the standard deviation just of the sample that we had. As we move forward, we're going to start talking about population parameters and population characteristics. And these also include things like the mean and the variance and the standard deviation, but these now have different symbols. And typically we're going to use symbols from the Greek alphabet in order to symbolize our population statistics. And we'll have some other variations of these different symbols that we'll use as we move forward. And again, sample statistics are figured from known information. They're the scores in our sample, and we're going to continue to see sample statistics as we move forward as well, particularly with our mean. Population parameters are usually unknown. Sometimes in one situation, particularly in the situation of the z-test, we'll talk about us knowing our population parameters. But usually these are unknown. Sometimes we're going to be estimating our population parameters from our sample. We'll get into that a little bit later in the course. But the important thing right now is to remember that the concepts are the same. The symbol changes, and so the symbol is going to be an indicator to us of whether we're talking about a sample or a population or an estimate of a particular statistic. We're going to be able to tell this from our symbol, and so we want to understand that the mean is always the mean, always means the same thing. Variance always means the same thing. But it's also important to pay really close attention to our symbols to know what these symbols mean so that we know when we're talking about a sample versus when we're talking about a population. Finally, what is hypothesis testing? Now we're really getting into the point here. And so hypothesis testing is the systematic procedure for deciding whether the results of a research study of a sample support a hypothesis that applies to our population. And in order to do this, we generally make a comparison. With hypothesis testing, we're comparing populations. Essentially, we're comparing the population based on our null hypothesis, which we'll talk about in a bit, and the population based on our research hypothesis, which is the hypothesis that we traditionally think of when we think about that prediction that we've made. And we need to ask ourselves if these groups are the same or if they're different. But then we wind up asking a slightly different question, which is if they're different, how different is different enough? You can imagine a situation if you have a friend in class who typically understands the topics about the same as you do, and you get similar grades all of the time. And so then you want to decide maybe to try out a new method of studying. And so you decide to do this other method. Maybe you decide to play a new review game that you've come up with. And you want to try to figure out now on the next exam, did this help you learn better? So you're going to compare your score on this exam to your friend's score. And so we can assume that you studied the same amount of time, you got the same amount of sleep before the test, everything else is the same except for your review strategy. If you get 2 points higher on this exam than your friend, is that different enough? What can we conclude about that? Can you conclude that this study method worked? Should you try to study this way before your next exam? Should you start telling your friends about this method and teach it to them so that they can be doing better on their exams? How do we know? And so how we decide how different is different enough is by asking if our results are statistically significant. And a result that's statistically significant is when the experimental results would rarely occur by chance alone. So if we think about the idea of you taking that exam and getting 2 points higher than your friend, that could be just random chance. There might not be a real reason for it. There might just be you happen to get one more question right. You might have gotten a slightly different score anyway. Just because you typically do similarly to your friend doesn't mean you always get the exact same score. And so in this case, when we're trying to decide if 2 points higher is different enough, we're going to ask, would this rarely occur by chance alone? And that's the idea of statistical significance. If it would rarely occur just by chance, then we're going to say that it's probably not by chance, it's probably because of our hypothesis, because of something about our design, about the manipulation that our experiment need, for instance. And typically we express statistical significance as a p-value, and that p stands for probability. And so our p-value is a percentage that shows the probability that the results are due to chance. And so if the p-value is showing the percentage or this probability that the results are due to chance, and statistical significance is when things are rarely due to chance, we want our p-value to be very low if we're going to say that our result is statistically significant. Generally, for social and behavioral sciences, we use a cutoff score of 5%. Sometimes we'll use a slightly different level for our cutoff score, and we'll talk more about that through the next procedures over the course of the rest of the semester. But 5% is a conventional level of significance. And 5%, if we move that and put that into decimal form, our criteria is that p should be less than 0.05. When p is less than 0.05, typically we're going to say our results are statistically significant. There's less than a 5% chance that our results are just due to randomness or due to a chance. And so we are going to say that there's evidence for to support our hypothesis. It's important to note that being statistically significant doesn't mean our results are important or meaningful. It just means that they would rarely occur due to chance. And so finally, we're getting into our hypothesis testing procedures. And as we go through the rest of the semester, really, as we go through these next several tests of different forms of hypothesis testing that apply to different situations, we're always going to have our step-by-step procedure. And while sometimes the way we complete some of these steps might change a little bit, these 5 steps are always going to be the 5 steps that we complete. And so we'll walk through these steps one at a time in this video, just so that we can hear these for the first time. And in the next video, we're going to start applying these to a particular situation for our first test. And so our first step here is that we're going to restate our question as a research hypothesis and a null hypothesis about populations. Our second step is that we're going to determine the characteristics of our comparison distribution. Next, we're going to determine the cutoff score on our comparison distribution. And this is the point that we've talked about related to statistical significance, the point at which we'll reject our null hypothesis. And we'll talk a little bit more about what that means in the next video. 4 is that we're going to determine our samples score on the comparison distribution. And lastly, we're going to decide whether we should reject the null hypothesis or not. And so these are our 5 steps. And again, these 5 steps are going to apply to every test that we cover from now until the end of the semester. The steps will always be the same, although sometimes a few of these steps will change in how we complete them. Particularly when we talk about our hypothesis testing procedures, our first and our 5th step are always going to remain the same. They're always going to be done the exact same way. In steps 2, 3, and 4, these are the steps that are going to continue to happen, but are going to change, are going to look a little bit different in almost every test that we do. And so again, we want to get used to these steps, but be aware that steps 1 and 5, learn them now, learn them well. They will continue to serve you for the rest of the semester. Steps 2, 3, and 4, we're going to keep remembering that these are the steps that we need to complete. How we complete them might look a little different as we move forward. But in the next video, we're going to focus on our first application of this, of hypothesis testing using the z-test.